Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper from the Hugging Face trending list, published on August 26, 2025, about 2 days ago. The standout idea is a generative judge that reasons step by step about a model's intermediate steps, then delivers a verdict, which yields substantially better judgment accuracy on those steps and even boosts end task performance. The paper is titled StepWiser, Stepwise Generative Judges for Wiser Reasoning. And as we will see later, the implications for model training are quite significant. Beyond accuracy, the approach improves inference-time search and helps train the policy model through reinforcement learning on step-level signals. On X, reaction centers on the generative judge concept, with posts highlighting meta-reasoning over intermediate steps, reinforcement learning training, and gains in judgment accuracy, policy improvement, and inference-time search. One post frames the core question about validating steps, another links the preprint and figures, and an automated summary reiterates benefits. Engagement looks solid, with around 166 likes on the first post and modest interest on others. Alright, the previous segment highlighted why judging intermediate steps matters. Figure 1 shows the end-to-end pipeline. The model first splits chain of thought into coherent thought chunks, then Monte Carlo rollouts estimate the success rate from each split point. The next panel labels a chunk as good or bad, based on whether success goes up or down, which supplies clearer supervision. Finally, a generative judge reads the question, previous chunks, and the current chunk, produces its own reasoning, and outputs a decision for reinforcement learning. So, the previous figure set up the pipeline. Table 1 details how self-segmentation should work, which matters because the judge needs coherent units to evaluate. The rules emphasize a single purpose per chunk, logical cohesion across lines, and a clear transition when the reasoning phase changes. The format guidance enforces chunk tags, output limited to tagged content, and strict preservation of original text and new lines, so each chunk becomes a reliable, self-contained step. Okay, the previous figure laid out the segmentation rules. Table 3 presents the exact prompt used to train the judge, which ensures the model reasons first and then commits to a verdict. The instruction block demands a step-by-step analysis that checks the new chunk against the problem and the history. The input fields specify problem, history, and the new chunk, and the output format requires an analysis section followed by a final judgment tag, positive or negative, so the reinforcement learning reward is unambiguous. Alright, the previous segment specified the judge prompt. Table 5 reports process bench results across 4 math suites, and the headline is clear. The generative judge with reinforcement learning tops all discriminative baselines. With QN 2.57B chunk and the relative effective signal, accuracy averages about 61.9, and with majority voting, it rises to roughly 64.1. Relative signals outperform absolute Q, which suggests progress-sensitive labels guide better judgments. So the previous table summarized benchmark gains. Figure 2 shows why those gains happen, by comparing ablations across reasoning steps and by tracking an offline baseline's loss. The left panel reports judge accuracy per step. The generative judge with reinforcement learning stays highest, the discriminative judge with reinforcement learning trails it, and rejection sampling fine-tuning lags. The right panel plots training loss for rejection sampling fine-tuning, which quickly plateaus, so offline learning cannot capture richer step signals. Together, these plots attribute the gap to both chain-of-thought reasoning and online reinforcement learning. Wrapping up, 2 takeaways stand out. A generative judge that thinks in steps delivers markedly better step evaluation, and online reinforcement learning with relative progress signals turns those judgments into practical gains for training and search. The broader implication is clear. Supervising the process, not just outcomes, can lift whole systems. That is it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.